So enjoy the struggle, right? If it doesn't kill you, it only makes you stronger. Yes, yes. Okay, let's try this problem. We are at example 6. A man walking away from a lamppost with a light source 6 meters above the ground. The man's 2 meters tall. How far from the lamppost is the man when his shadow is 5 meters? We won't say feet. We'll all work in meters. That would make it easier. 5 meters in length. Okay. What do you want to do first? Draw a picture and make some triangles. Very good. So I'm really good at drawing. Sydney said she's kind of artsy. You want to come up and draw our lamppost? All right. Well, if you laugh at mine, then you're going to be in trouble. I don't see anything wrong with my drawing. All right. So this is 6 meters. This is 2 meters. And then he's got a shadow that's 5 meters in length, right? And I heard Clarissa tell us that this makes a triangle. Yeah. Everybody see the triangle? There's a big triangle. And we want to know how far he is from this spot right here, from this lamppost. We'll call that X. We're wondering what X is. Now I'm going to draw another triangle. Do you see the green triangle? A for the day. Are those triangles similar? Why? They share one angle in common. This angle's the same. Those are right angles. Why do we know those are right angles? Because they measure height. And we know that height is always 90 degrees. So if two angles are the same, then the third angle has to be the same. And you guys all remember from geometry that if two shapes are going to be similar, their angles all have to be congruent. So if two shapes are similar, their sides are proportional. Very good. Yep. Generally, perpendicular and parallel come out. I had to get a little bit further in the and then first hour got it. So you guys were a little bit ahead of the game, but you're the smarter class, so good job. I'm waiting until they watch and they come back. See, it hasn't happened. I know people aren't watching my videos yet because I've been making cracks at first hour, and they never come back and say, "Hey, you're pretty mean to us." So we'll wait till they do. Yeah, first hour is horrible. All right, okay, here we go. Well, maybe they'll actually come back and say something about it. So we'll wait. All right. They're really great class. No, you terrible. All right, so we've got proportional. So we do, like, if you want to set it up, we could say their height divided by their shadow. So every time we set up a proportion, some people say, well, I don't know what to put on top. I don't know what to put on bottom. You decide. If you want to do shadow over height, that's fine. If you want to do height over shadow, that's fine. You decide. But you just got to have rhyme or reason what you're doing. So what's the height of the man? 2 over shadow. 5 equals height of the lamppost over plus 5. The entire length of this triangle. Now I cross multiply. See an equal sign with 2 fractions. Cross multiply. 30 equals 2x plus 10. Subtract 2x. Well, I'm sorry. Subtract the 10. And I've got 20 equals 2x. 10 equals x. Does that answer my question? The question is, how far away is the man from the lamppost? X does determine that, so 10 meters is correct. Piece of cake, right? That was a nice one. You're like, hey, this is easier, right? Disappoint you? Carissa is saying, if you only show me the easy problems, my brain will start to mold, and I don't want that to happen. So give me something more difficult. All right, we'll do it. We'll do it. Okay. So last hour really didn't like this. First hour is okay, but this last hour really didn't like this. John can paint a house in 32 hours. Eric can paint a house in 24 hours. How long will it take them to paint one house together? If I add those two numbers together, I get 56. Why would it be absurd to say it would take them both 56 hours? Yeah, it should be less time. I mean, if Eric can do it in 24, why would it take him twice as long as if he had help? Here's another thing that people might do. They might add them together and divide by 2. No, not that you would, but somebody might. And if you add them together and divide by 2, you get 28. Well, 28's absurd as well. Why? Yeah, it's still more than Eric. So how about this? What if John and Eric both took 24 hours to paint a house? The exact same amount of time, 24 hours. How long do you think it would take them if they did it together? 12. It would seem like each one would paint half, and it would take them just half their time. So 12. I would agree. So if it takes John 32 and not the 24, would you expect that their time would be more than 12 or less than 12? More than 12. So we know that the amount of time it takes is going to be greater than 12 but less than 24. Would you agree? Now, the only reason I do that is just to try to get context of what type of solution it might be. And what I just did is a skill that as math people, as you mature as math people, you want to try to do that. You want to try to think about possible solutions that are reasonable. That's a really important skill. So here's another equation that we need. Maybe you know this equation. Rate equals distance over time. Do you know this one? Now, in this one, we're not talking about distance, are we? We're talking about painting houses. So we could say the rate is equal to the number of houses divided by the time it takes. Would you agree? I'm going to multiply both sides by t. Rate times the time is equal to the number of houses. And they don't give you these formulas on the MCA. They don't give them to you on the ACT. These are ones that they've said you've had for a number of years. You need to know how to work with them. So I'm going to set this up for you, okay? John's going to do a certain amount of work. John might paint. Is John going to paint more than 50% of the house or less than 50% of the house? He's going to paint less because it takes him 32 hours to paint one. Whereas is Eric going to paint more than half the house or less than half? He's going to paint more. If you add John's work together and Eric's work together, how many houses will they paint? They'll paint one house. So here's the formula that I'm going to use now. I need to write an expression for John's work. Okay? John's work, the amount of a house that he paints is equal to his rate times his time. John paints how many houses? One house every how many hours? 32. That's John's rate. One house every 32 hours. Eric paints how many houses? One house every 24 hours. So for John, the amount of work that he does is equal to his rate, which is 1 over 32, times how much time does it take him to paint this house? Right, we don't know. So we'll call it T for time, but X, you're exactly right. If you want to write X, that'll be fine. Plus Eric's work. What's Eric's rate? 1/24 times time. True or false? If they're painting the house together, it will take them the same amount of time. True. For example. Okay. All right. So let's say that Caitlin, okay, is let's say that we both make cookies, okay, and let's say that she makes 100 cookies in an hour, and I make 2 cookies in an hour because I'm really slow. Okay. All right. If we work together, we're gonna finish that job at the same time, right? Who's gonna do a greater percentage of that job? She is. Well, we're going to both spend the same amount of time working on it. It's just I'm not going to get as much done. So as you see here, John's not going to get quite as much done. Eric will get more done. They will spend the same amount of time, and they will complete exactly one house. So now we have enough information to solve this equation. T over 32 plus T over 24 equals 1. So T over 32 plus T over 24, if I want to solve that, equals 1, what do I have to find? Common denominators, 32 and 24 both multiply to 96. So I'm going to multiply top and bottom by 3, and top and bottom here by 4. So on the top we get plus 4t all over 96 is equal to 1. Can we simplify the numerator? Yes. 7t over 96 is equal to 1. How do I get rid of the 96? Times it by 96. So 7t is equal to 96. Divide by 7. Time is equal to 96 divided by 7. Can somebody take 96 and divide it by 7? So it takes them 13.71 hours to do it together. Does that make sense in context of a reasonable answer for us? Yeah, it's bigger than 12, it's less than 24. Now, I didn't show this to last hour, but I want to do one more thing here, okay? Because I think it's important that you find this out, okay? If the time is 13.71, we should be able to plug it back in and make it work. Now, I'm not going to do all that, but can somebody on your calculator take 13.71 and divide it by 32? What do you get? 13.71 divided by 32. 0.428? So 42.8% of the work is done by John. Now take 13.71 and divide it by 24. So 57.1% is done by Eric. So you can see that together they do 100% of the job. 99.9%. So we rounded off, so didn't get exactly 100. We'll just, there we go. So there you go. So it does work out. It makes sense with how we did it, but that's how you got to set it up. Okay. So when you get to one of those in your assignment, follow exactly with this problem. I've got a couple of them for you, and there's a little twist to one, but we'll see if you can get it. If you can't, I'll do the problem for you. Okay, one more. Well, before I move on, any questions or confusions on that part? Because the other hours had some questions or confusion. Okay, last problem. Distance, rate, and time. After robbing a bank in Dodge City, the robber gallops off at 14 miles per hour. 10 minutes later, the marshal leaves in hot pursuit at 16 miles per hour. How long does it take the marshal to catch up with the bank robber? Everybody loves this problem because it says gallops. And I say, well, he's riding a horse or a donkey or an elephant or something like that. Okay? And they're like, Dodge City? And I said, well, you know, it's like the Old West. Everybody thinks I wrote the problem. I just took it right from your book. So, all right. I'm going to draw a bank. It's got money inside of it. And what color do you want the robber to be? Black? All right. Yeah, face mask. There you go. I got you. I'm right there with you. Okay. And at some point he gets caught, right? Do they not get caught? He's too slow. Exactly. He's going at 14 miles an hour. And Marshall leaves at 16 miles an hour. So one will overtake the other at some point, okay? So we'll say this, 14 miles per hour. There you go. All right, we'll say the police are red. Come on after them, and eventually the police catch up, right? And their rate is 16 miles an hour. But there's something important that happens here. This guy got a head start. Did he not? So we'll have to take that into consideration. Out of these three items, rate equals distance over time, rate, distance, time, you tell me which one of those is the same for both the robber and the marshal. Distance is the same. They cover the same distance because that's when they'll be overtaken, right? So what we have here is we have the marshal distance and we have the robber. Distance. And you told me that those are going to be equal to each other, right? So if I come up with an expression for the marshal distance and an expression for the robber distance, then I should be able to set them equal to each other. Well, I know that distance is equal to my rate times my time. By simply multiplying both sides of the equation by t, I get distance is rate times time. What is the rate of the marshal? 16. How much time is he galloping for? X or t. Very good. What's the rate of the robber? Times what is his time? T. Except he's got a head start, so he's already a certain amount ahead. Good ideas, not quite. Let's see exactly what's happening here. His head start is a certain distance, right? And we said that distance is equal to rate times time. So let's figure out what that head start is. What is the rate of the robber? 14 times, how much time has he been galloping for, or running off for? 10 minutes. So for an hour's 1/6 of an hour. So his head start is his rate, which is 14 times 1/6 of an hour. 7/3. So the robber distance is 14t, but you got to add on that 7/3, which is his head start. Sure, go ahead, change it to decimal. I won't, because I like fractions. All right, so we're going to subtract 14t from both sides. We get 2t is equal to 7/3. Then I divide by 2, and I get time is equal to 7 over 6, which is the same thing as 1 and 1/6, or 1 hour, 10 minutes. Tricky, tricky, tricky. Got it? Okay, so I got 4 more problems for you to add. You have the rest of the hour to work. You have all of tomorrow to work in class. Yes, I will go back to that. Your assignment, so don't write down these 5. You wrote that down yesterday. You guys all got it done because Monday Night Football was not worth watching, and you said, I'm going to do my homework instead. All of you guys are like, there's Monday Night Football? Yes. Peyton Manning was playing last night. He threw like 5 more touchdown passes. Okay. 48, 53, 54, and 59. And I will be happy to help you with any homework questions you have. I will let you guys know when I'm setting one up on the board in case you want to watch. Whoop. So, some people want to see the end of this, right? There you go. I'm going to stop it.